All right, good day. Welcome to Math Made Easy. Today we'll continue on geometric progression, and we are going to look at sum of a geometric progression. Sum of a geometric progression. This because it's a lot and bulky. I'm not really going to explain certain things about it because that's three formulas actually. So there are three formulas for sum of geometric progression. Sn equals to a r is power n minus 1 over r minus 1. Sn equals to a 1 minus r is power n over 1 minus r. Sn equals to a over 1 minus r. Now, this one, you use this one when r is greater than 1. You use this one when r is less than 1. And you use this one when r tends towards what? Infinity. They will give you the question r tends towards infinity. You use this one. Now, um, for um, for you to understand better, I will explain this in fraction because most times when you hear r is greater than 1, you know of 2, 3, 4, you know of 2.5, all those things, right? But when it becomes fraction, you might get a little bit confused if you really don't understand your fraction very well. So when it comes to fraction, here and here, once it is a proper fraction, it falls under here because proper fractions will always be less than 1. Proper fraction means that your numerator is less than your denominator. Once your numerator is less than numerator the one up, denominator the one down. Once your fraction is a proper fraction, it falls under r less than 1 because every proper fraction is always less than 1. Do you get it? So um once it is a proper fraction, it falls under r is less than 1. But once it's an improper fraction, right? Let me for now. Let me 7. Let me 7. Improper fraction meaning that the numerator is bigger than the denominator. It falls under r is greater than 1 because every improper fraction will always be greater than 1. So that's the logic to understand because sometimes your common ratio might be given to you in fractions. So once you see that it is an improper fraction, you know that it's r is greater than 1. Once you see that it's a proper fraction, r is less than 1. So look at these formulas. So we can have a question where we have um this. It's two variation of question I always give. So, but no, let me not give two variation. If I give you this type, it will just be quite too easy. So let's give if the first term of an of a GP is 3 and its common ratio is 1 over 3. Find the sum of the first 10 terms. Now, this will actually give me, let me use 5 because I don't want to use, it's actually give me a very large number. But now look at this. Let's solve it. First term is what? 3. Common ratio is what? 1 over 3. Now looking at this, it shows that it is proper fraction, meaning that it is r less than 1. And for r less than 1, if you recall, the formula is Sn equals to a 1 minus r over raised power n over 1 minus r. So our S5, which is sum of the first 5 terms, will be 3 open bracket 1 minus r is what? 1 over 3, right? N is 5. Do you get it? Then 1 minus 1 over 3. So equals to 3. 1 minus 1 over 3 raised power 5 will give us 1 over 243. 1 over 243 over 1 minus this will give us 2 over 3. Now, if we have 3, 1 over 243 will give us 1 minus 1 over 243 rather will give us 242 over 243, right? Over 2 over 3. 3 here 1, 3 here 81. You get what I did? This don't do this divided by this. You cannot work, but this is like saying 3 times 242 over 243. That's how I could divide. So we have 242 over 81 over 2 over 3. Now bring it 243, 242 over 81 divided by 2 over 3. 242 over 81 times 3 over 2. 3 here 1, 3 here 27, 2 here 1, 2 here 121. So our answer is what? 121 over 27. If you want to leave it in mixed fraction, because this is improper, don't leave in mixed fraction, we are going to have 4 whole number. Yes, 13 over 27. So if you look at it, we did for r less than 1. This is the formula. You get it, then we worked it like that, like that, like that, like that, like that, and we got our answer. I think I'll just do for r tends to infinity. They will tell you, most times they don't give you the question, but if they give you, they will tell you that when your common ratio is tends to infinity or going towards zero, they get it. So most times that's what it means. So the second example I'm going to have, I'll use the example we used earlier, but I'll not calculate it. I'll calculate it, but you do the calculations yourself. Now, look at this. We have there was a question I wrote when I was teaching GP. Okay, if the fifth fifth term and seventh term of a geometric progression is rather I think 243 and 2187. If I'm not mistaken. Find now I think I wrote common ratio, abi first term, find A, find common ratio, B, find first term, and I think I wrote another thing for you to find. Can't remember now. Now imagine that the fourth question here now tells you find the sum of the first 10 terms, the sum of the first 10 terms. Now, having gotten this, we know that our common ratio, if you remember when we solved it, we found out that our common ratio was 3, right? Our first term 2 was 3, right? So we look at this place and we know that r is greater than 1. So the formula we're going to use for r is greater than 1 is Sn equals to what? A r is power n minus 1 over r minus 1, right? So our A is 3. So when you say the sum of the first 10 terms, sum of the first 10 terms, so we're going to do S10. Now I'm only doing for this one because I assume that we've done this already and I told you to do this. So S10 equals to A is what? 3, R is what? 3, our N is what? 10 minus 1 over 3 minus 1. So we have 3. Now this will be the problem. 3 is power 10. 3 is power 10. Use your calculator. 3 raised power 10 is 59049 minus 1. So 3 minus 1 is what? 2. So we have 59049 minus 1 will give us 59048 over 2. 59048 over 2. So if we do it to calculate it, we just multiply this times 3. So we have 177,144 over 2. So divide it by 2 and we get what? So our S then will be what? 88,500 and what? 72. You get it? So basically, the most important thing for you to understand is how to get R greater than 1 and R less than 1. See you in the next class.